Lesson 4.4, Matrix Addition and Subtraction. We can handle arrays of numbers algebraically as well, and we would call this a matrix. And so we can perform operations with them, such as a plus b equals c, and some familiar ones, like, for instance, we can multiply a matrix by some scalar, like the number 5 or something of that sort, or even the number 1. If we wanted to subtract two matrices, we would multiply a plus b, okay? Then we could multiply b by minus 1, and then so a plus the negative of all the components of b. So what do I mean by the components or the elements? Okay, so a plus b, this is going to be a 2 by 2 matrix here, 2 by 2 array, and the elements are going to be A11, A12, A21, A2. Those are the addresses. We're telling you where they are. Okay, and so what we're going to do to find matrix C is we're just going to sum all of the elements that are in a like position. So C has as its first element, C sub 1, is A sub 1 plus B sub 1. And again, A sub 2 plus B sub 2 is the last element of the array. Okay, so let's do an example here. We're going to sum the matrices G and H. We're going to stick with G and H. G and H are going to have their same definition. So G is the 2 by 2 matrix 1, 2, 3, 4. 1, 2 in the first row, 3, 4 in the second row. Okay, and H is going to be minus 3, 5 in the first row, and then 2 minus 1 in the second row. So we're going to do a couple of examples, and these are going to stay the same. So you can come back up here and you'll look at what G and H actually are. Okay, so if we sum G plus H, we're going to take the first element of G and we're going to add it to the first element of H. So G plus H, 1 plus a minus 3. As you might have guessed, that's minus 2. Okay, so the second element here would be 2 plus 5 is 7. The third element, 3 plus 2, 3 plus 2 is 5. And the very last one, 4 and minus 1 is equal to 3. And that's how we sum these. If we subtract it, what we can do is we can take G minus H, and we can turn that into, here's G plus minus 1 times H. We go ahead and we take that scalar, minus 1, and we're going to multiply minus 1 times every element of H. So minus 3 becomes positive 3, 5 becomes minus 5, 2 becomes minus 2, and minus 1 becomes 1. And then we add the same way we did before. I'll just do the first one here. 1 plus 3 is 4, and then maybe 4 plus 1 is 5. All right. This is going to look a little more similar here. We have coefficients out in front of our matrices, and we're going to evaluate 4G plus 3H. Well, 4G plus 3H would just simply be 4 times the matrix G plus 3 times the matrix H. We're going to multiply 4 times every element of matrix G. So 4 times 1 is 4, right here. 4 times 3 is 12. 4 times 4 is 16. Okay. Over here, with H, we're going to multiply every element of H by its coefficient. Okay, well, the factor of 3. So 3 times minus 3 is 9, and 3 times minus 1 is minus 3. And then we sum in the same exact way we did in the previous two examples, and we arrive at our result. It's a new matrix. If you have any questions, please be sure to post them in the discussion board. Remember, those questions you post in the discussion board count as participation. If you're struggling to find something to ask about or comment on, that's a good way of doing it. Okay? I'll see you in the discussions.